Involta is a multi-tenant data center provider. We have 7 data centers across the country in secondary markets.
The Involta Tier 3 data centers have redundant diesel generators, redundant electrical supply to the equipment, and redundancy with respect to all the cooling. A Tier 3 data center brings up the concept of concurrently maintainable, where you could take a piece of equipment out of service so as to maintain it without reducing the ability to serve cooling, electrical, or other physical environments.
We chose Involta because they have dual circuitry and dual power generators. I know that they put a lot of effort to put themselves as a high-end data center who provides the same services as major metropolitan data centers.
Involta Marion is 18,300 square feet. We have 300 racks at 2.7 kW per rack. The building is supplied by 2 feeds from the utility service. That comes from 2 different substations through independent 2,500 kVA transformers, each capable of running the entire facility. And then we go into a switchboard that allows for 4 diesel generators to interact with those 2 independent power sources. And then we go into 2 900 kVA isolated dual UPS buses to each of the equipment racks. Involta uses an A-B supply system to each and every rack. Most of the IT equipment has dual power supplies. That is 2 power supplies within a chassis or within a server. We plug one of those into A and one of those into B. So you always have 2 sources of power. If something were to disrupt one source of power, the other source of power would go unready to serve. Involta utilizes copper distribution to all of its data centers. We use copper from the switchgear on down.
The Involta Akron data center facility is 26,400 square feet. The substation takes in 13.8 kV of power. Grounding, as you see on the transformers, goes down, and that goes down to tie into the ground grid that we have buried below the subyard. You'll also see in the background that we have that coming off the columns that support the busway areas for all the power distribution coming in. A lot of times we're talking about the premier items, the power, the cooling, the infrastructure, security and such. Grounding always seems to be that lost item, but it's one of the most important, if not the most important component to ensure that power stability and delivery. For proper grounding, you need to use the right conductor, and that should be copper because of its reliability factor.
Whether it's our switch yard with a web of grounds underneath, or it's our data center equipment or our data center loads, the actual server equipment, all of those have to eventually come back to a ground that makes good connection with Mother Earth. And so we can use a variety of rings to do that. And what you'll see in our data centers is a ground wire for the racks to tap into, and then a ground bus for the equipment to tie into, and then a transfer of the outside building protection and those 2 buses into a single common potential or the main ground.
We have both a horizontal and a vertical grounding component here, with the ground rod being driven into the ground, minimum of 10 feet, and the horizontal aspects of the ground's going around the perimeter of the building itself.
The Involta data centers have transient voltage surge suppression in 2 ways, a system specifically designed for that, and then we also want to isolate harmonics, so we have some isolation transformers associated with our load.
At a previous company I was at, we had aluminum power feeds, and the biggest challenge we had there were the lugs would come loose on a very frequent basis. So to overcome that, we enlisted a local engineering firm who came in, reviewed everything, made the recommendation to go to copper. Once we did, we eliminated a lot of the frequencies of having electricians coming out all the time to check lugs, and also ensured ourselves that we had reliability from that copper for our power delivery. What you'll find in Involta facilities is that we don't cut corners on our power equipment and our cooling equipment, or in the infrastructure necessary to move that power through the facility. We have to have the reliability of copper in our power infrastructure so that we have peace of mind at the end of the day in the operation of our facilities.